So my name is David Steele, as you probably know now if you speak Russian, and I am the, wait a minute, hang on, sorry, I looked over and it wasn't my laptop. I'm like, what happened? That's weird, wait a minute. I seem to be missing a slide. Anyway, I'm the principal architect at Crunchy Data. We're based in the United States and we do most of our stuff there, although we're reaching our tendrils into Europe a little bit as well. So today we're going to be talking about pgBackRest, which is a tool for dealing with not only backups correctly and efficiently, but dealing with very large volumes of data. Now, I've been giving this talk for almost 3 years now, since before Backrest was, when it was an early beta. You might even call it alpha, even though there were companies running it in production because they had no choice. It was the only thing that was big enough to do what they needed. But what I found the last time I gave this talk is the feature set for Backrest has now gotten so large. It used to be a review of the feature set and then a demonstration. And then I outgrew the demo. You're much better off just going to the user guide on the website because there are tons of examples there. And I found that in my last talk, I've actually even outgrown talking about the entire feature set. There simply isn't enough time in a talk like this to do it any justice. So at Ilya's suggestion, I'm going to take a slightly different format this time. I'm going to go through some of the slides kind of quickly, and then I'm going to spend more time on the slides or features that I find are particularly interesting and give you a little more insight into architectural decisions, why we did things the way we did, what we're trying to accomplish, how it might help you. So if I go past something really quickly that you're interested in, just let me know. I'll go back, or I can say things. So partly what I'm saying is, if you want to ask questions during the talk, that's fine. I want this to be a little bit more of an open dialogue than I've done this talk in the past. So let's get started. Here's our agenda. We're going to, hang on a second, let's see. There we go. We're basically going to talk about really quickly why you should back up. I don't think this should be a big sell, but we're going to go through some of the reasons and benefits, like things you can actually get from it. It shouldn't have to be a chore. We'll talk about this concept of living backups really briefly, and then we'll go into design, features, performance. We'll also talk about changes we've made to core to make backup work better, things that are in the pipeline. So that's our basic agenda. All right, so backup. We're going to go through this pretty quickly, but obviously you've got the obvious things. You've got hardware failures. You've got wall archive to keep your replicas fed. You may not always be able to get the wall from the master, so the wall archive can be a great place to get it. You can build your replicas from your backups instead of from your master, reducing load on your master. You can detect corruption and fix it. Right now, the only way to know that you have corruption is to maybe try to PG dump your entire database or get lucky. If the corruption's in the index, you may not find it. Backrest will detect page-level corruption for you and let you know when it happens, so you have the choice of going back to an older backup and restoring. So you might have had an accident. Maybe someone just accidentally dropped a table or deleted your most important customer account or that sort of thing. Development. There's no more realistic data than production, so if there aren't, like government or privacy reasons why you can't do it, using your production database for development can be really beneficial. Also reporting. So rather than doing reporting off of your primary, you can stand up a reporting server, especially if your reporting is daily, and you can sync up your server or do a restore and then disconnect it. You can use temp tables, you can do all that good stuff, and you can do your reporting. So there's lots of ways that you can use your backups, not just for disaster recovery. And in fact, well, sorry, I forgot about this slide. So this is extremely important. If you are not restoring your backups and you're not thinking about your backups in terms of full life cycle, they probably will not work when you need them. Not only may there be something wrong with the backup, or you discover that the cron job was disabled 6 months ago by your newest employee, no one's going to be familiar with the process. So you need to be familiar with the process. And so in order to do that, you need to find a way to make backups useful. You need to get them into your enterprise in one of those ways that we discussed. And you need to remember this very important thing, that if you've got code paths or procedural paths that aren't being followed regularly, they're almost certainly out of date and don't work. And you really don't want to be the first time someone's doing a restore to be a mission critical time when your primary server has gone down. You want the people in your admin group to be familiar with doing backups and restores, with bringing up replicas, and this should be second nature to them, so by the time something bad happens, you can deal with it quickly and effectively and with confidence. I mean, a lot of times when things go wrong, it's because people aren't confident, they get nervous, they make mistakes, they get more nervous, they compound those mistakes. So the more confident people are, the more likely you are to get a good restore and recover from disaster recovery quickly. So that's pretty much the end of my lecture on why you should be backing up. There seems to be a pretty good crowd here, so maybe I don't have to convince you, but think about integrating backups into your enterprise and how you can do that and how you can make them living backups, like full life cycle, not just for the chance that your master goes down, which frankly with Postgres doesn't happen that often. Most people are able to recover their masters, so that's not your general use case. It's your worst case use case, right? So let's talk about backrest design. Oop. So why was backrest started? Backrest was started because the primary tool that's used for Postgres backup is rsync. So whichever tool you're using, you might be using something like Barman or something homegrown, but most backup solutions are built on top of rsync. Rsync has a number of limitations. The biggest one is that it is single process, right? This is a problem for very large databases. It's just not fast enough. It also has a problem that it only has a 1-second timestamp resolution. So if rsync is copying something and Postgres is modifying something at the same time, your next differential backup won't pick up that change. So rsync is not safe for differential backups, and unless you use checksums. If you turn on checksums, it's fine, but if you're using timestamp-based differential, it's not safe. The other thing is that the way incremental backups are done with rsync, it requires the previous backup to be uncompressed. So now you've got at least 2 backups that are uncompressed in your backup set. If your database is very large, 15, 20, 25, 30 terabytes, this is an extraordinary burden because database data compresses fairly well. I regularly see 75 to 80% compression. So it's just unacceptable to have uncompressed backups laying around. So the idea with backrest was to, and don't get me wrong, I've been working with Postgres since 1999, and I've been using rsync except for the last 3 years. It's seductive, it's easy, it gives you most of the functionality you need, and when databases were smaller, it worked. So the idea with backrest was to go back to fundamentals, come up with a backup solution that was designed for Postgres, for databases. Rsync was not designed for databases, it was designed for moving archives around the internet, right, and creating mirrors. A database does not work that way, they're not the same problem set. So essentially we decided to get rid of all the typical backup tools, tar, rsync, all of it, start from scratch, write our own stuff. And also to natively support local and remote operation, which we felt was extremely important, and also solve this timestamp resolution issue, which actually turns out to be really easy. We'll talk about that later. So at the core of it, you can kind of read through these bullet points, but the core of backrest has always been about doing things in a multi-process way, right? Take the problem. The great thing is copying files is an excellent place to do multiprocessing. You can easily generate a manifest that's very quick, right? And then you can divvy those files up between a number of processes. We actually do it dynamically so that no process gets too much data. So the processes are fed data as they go, so it's nice and even across the board. You start with the biggest files, you work your way down to the smallest files, and table spaces can be split among different processes to optimize I/O, et cetera, et cetera. But everything we do in backrest, we're thinking about multiprocessing. How can we parallelize this problem and make it more efficient? Even not everything in backrest is parallel. We'll talk about some of that. But everything can be parallelized. Everything is designed in that direction. In some cases, we just haven't inserted it yet. So this is extremely important that we support local remote operations. So you might be backing up to NFS. That we would consider that to be local operation. Some cases, people actually back up locally and then have a backup server pull those backups off and move them away. You might have your own backup server running a backrest process where you centralize all of your backup scheduling. You might be backing up to S3. So there's lots of different options to do local, remote, combinations of those. You can actually have a backup server which is then moving stuff to S3. So you can centralize your configuration and your cron jobs and things like that. But this is extremely flexible. There's lots of different ways you can configure it to get your backups in the place they need to be for maximum safety. So we do full incremental and differential backups. Anyone here know what a differential backup is? Okay, so I didn't really know what a differential backup was before I started this project, but a differential is an incremental that's always based off the last full backup, right? So if you want to reproduce a backup from a differential, you only need two backups, the differential and the last full. Whereas incrementals can be based off of each other, and you can have long chains of incrementals. They can be efficient, but they're also harder to expire because there are so many dependencies, you have to expire entire chains of things before you can get rid of them. And as I said earlier, backrest is not susceptible to the time resolution issue. It turns out the solution to this problem is very simple. You build the manifest, which is the list of all the files that you're going to back up, and then you wait till the end of the current second to start copying. So that's it. So you just wait that time period. And so if Postgres modifies the files during that time period, that's fine. If it modifies them the next second, they'll get a new timestamp. And then you start copying. It's that simple. So there's no real magic to it, but again, rsync was not designed for backing up databases, and it doesn't do this. So, easy solutions. So built into backrest is backup rotation and archive expiration. So you can set retention limits for your backups. You can decide how much WAL you're going to store. You can actually store WAL for all your backups, or you can store WAL for just some of the most recent backups. Now, if you do that, the only thing that backrest will expire is the WAL in between the backups, because the WAL that was actually collected during the backup is required to make your backup consistent. So whatever that set is will be kept. And then you'll start to see these gaps appear. So what that means is you can still recover a consistent backup, but you may not be able to do point-in-time recovery to a certain point from those older backups. I encourage people to keep all their WAL if they can, if they have space. Backup integrity, all right? This is something we have spent a lot of time thinking about. So earlier I said if you're not restoring your backups, they're probably not any good. And philosophically, that is definitely true. But we've done a lot to try to make sure that if backrest says you have a backup, that you really do have a backup. Some of the ways we do that, one thing is we actually validate all the Postgres page checksums, right? So this is only good on 9.3 and above, and it's only good if you've enabled them at initdb time. So obviously, if you have an older database that you've been PG upgrading, you're not going to have checksums. Checksums are also not on by default. I encourage you, if you're doing an initdb, always put -k. The overhead is very small, and the payoffs are very big in terms of knowing if you've got some bit rot, pages that drop, some SAN problems, some controller problem. This will let you know. Now, backrest does not error out when this happens. It just starts putting warnings in the log, and the backup completes normally. But at that point, if you want to, you can go to an older backup and recover, because maybe the error was only on disk, and maybe the error is not in your WAL stream. So if you recover an older backup and replay, you may be able to eliminate this corruption. But the important thing is at least you know it happened. Because maybe there's nothing you can do about that one particular block, but at least you know, hey, there's a problem. My controller's bad, my disk's bad, something's bad if I'm getting bad blocks popping up, and you can deal with that problem early instead of 2 years down the road when you've got bad blocks peppered through your entire database. We calculate checksums for every file in the database, SHA-1 checksums. So, and these are rechecked on a restore. So if the checksums don't match, the restore won't work, right? And you'll be notified. So if let's say after the backup is complete, there's some corruption in the repo, This will help detect that. It also checks after the backup to make sure that all the wall segments made it to the repo, right? So if you don't have those wall segments, you don't have a backup. This is very important. So we verify that those wall segments are there for you. You can turn it off. There are some times when you're doing your own archiving or some other thing. So we allow you to turn it off, but the default is to check it. We also use a really simple backup format. So inside the BackRest repository, the clusters are stored just as if they were a Postgres cluster. And this includes even creating the tablespace links internally. So if you're, say, using something like ZFS, you can snapshot the BackRest repository and bring up the database in place. Now you still have to do wall replay, so it may take a little bit of time, but you don't have to make a copy of the database in order to bring the database up. For very, very large databases, this can be very advantageous because they can be compressed and with ZFS, and then you can actually bring them up in place and dump out development data, pull that table that that person deleted or the account they deleted, and you don't have to bring up the entire system. So this is another way where we really think about terabyte scale databases. How do you work with them effectively? How do you work with them efficiently? And all operations utilize file and directory level fsync to ensure durability. The interesting thing is I was working on this at exactly the same time that in Postgres we were cleaning up a lot of areas where we realized that directory fsyncs were not being done correctly. And I was talking to Andres and others at that same time and making sure these same protections got into the backup tool. Because you don't want the backup tool to tell you that the wall archive has been created and then it's not, right? This is extremely bad, so you want that to be correct. Resume, so I'm just gonna gloss over this, but very quickly, if you have a backup that fails, BackRest can use that backup. The next time you schedule a backup, it'll reuse as much of that backup as it can. Now it still has to do checksums, but it reduces the load on your master on the next backup run. So it can be very handy. This is sort of a philosophical thing. In BackRest, everything is done in stream, okay? So nothing is ever done at rest. So if you're pulling the file from your database, it lives in memory until it sits on disk in a compressed format at the end. And checksums aren't done on files at rest, et cetera, et cetera. Everything is done in stream. Compression isn't done more than once. So if your transport protocol is SSH, for instance, we disable compression in an SSH. Compression is done on the database server, and then that file is stored on the destination. This happens one time. When the data comes back during restore, that original file is transferred over, and it's decompressed on the database server. So files are touched as little as possible. Operations are done as few times as possible. This is for performance primarily. Delta restore. Okay, so this is a very interesting feature. So I always tell people, back up as slowly as you can, right? You don't need to back up quickly. You don't want to put that load on your system. You don't want to put any more load on your system than you need to do your backup. So if your weekly full backups are happening within a day or even 2 days, that's okay. That's what the wall stream is for. Your daily differentials or incrementals, if they're happening in a couple of hours, that's fine. Don't devote any more resources to backup than you need to. However, the thing that you do want to be really fast is restore, right? Especially if this is a DR situation. So your primary server has gone down, you're building a new primary, or you're building something. Hopefully you can just fail over to a replica, right? This is your usual situation these days. But in the case that you need to do a restore, parallel delta restore is a really great tool. So what this does is it compares the manifest against the disk. It deletes anything off the disk that isn't in the manifest, right? That's the first step. It's nice and easy. And then all of the files that are the same between the manifest and the local system, it starts doing checksums on them in parallel. So you can define your degree of parallelism here. It works pretty well because, of course, sequential I/O, and you're using a certain amount of CPU for the checksumming. So I've done this up to 64 ways on big systems, and it will very quickly determine what it needs to pull from the backup. And as it goes, every time to find a checksum that doesn't match, it'll pull that file from the backup, and then it continues on. So you can see, you can actually have a 10, 15, 20 terabyte database that will restore in a few minutes. You know, it depends on your delta. If you're going through and changing every segment of every table every minute, well, your delta is going to be very big, and it's going to take some time. In theory, the delta method could take longer than a clean restore if everything had changed. But in practice, that's not the way it works. In practice, you know, large parts of the database will remain static, especially if they're data warehouses. You know, multi-terabyte databases tend to be partitioned, and they tend to have kind of a data warehouse mentality, so you can get a lot of efficiency here. So this has been used to great effect for, you know, to many people. So this is another area where we're thinking about how do you deal with big data? You know, what are the effective and efficient ways to get things backed up and restored and moved around as quickly as possible? Another really, you know, it's interesting because when I started this project, like a lot of you, who here has written their own archive command? Show of hands, anyone? Okay, a couple of people. You know, when you start with an archive command, it looks pretty easy. You're like, okay, well, Postgres calls this, and then I just move this file over here. It can't be that hard. But as you get into it, and especially with a piece of software like this, where many people are using it, you start to find all the edge cases. What happens if the file gets written properly, but on the way back over the network to notify Postgres, that packet is lost? Well, Postgres will try to repush that file because it doesn't know that it succeeded. So now you've got to determine, is the file I have already the right file? Should I just keep what I have, or should I give an error because now I've got a WAL file with the same name but a different checksum, etc. So you want Postgres to silently succeed if it was just repushing the same file. You want a failure if they're pushing from another database or a database on a different timeline, or you know, some other horrible thing that's happened that's indicating an error. People love to copy WAL segments around kind of randomly, and this causes all kinds of interesting problems for archive functions. So what we've done is we put in a whole bunch of, that's not what I meant to do. We put in a whole bunch of checks to make this thing work. So first of all, we have dedicated commands for pushing WAL and retrieving WAL, rather than saying, hey, use rsync or use CP or do whatever. It's all built in, and it's all part of the backrest system. The push command, like I said, automatically detects when WAL segments are pushed multiple times and deduplicates, you know, otherwise it gives an error. Both of the commands will check to make sure that the database and repository match. So when you create a backrest stanza in the repo, it pulls critical information out of the database, the system identifier, the version number, and it stores that in the repo. So it knows if the correct database is talking to it. It's really common for people to accidentally, let's say you're setting up a new backrest repo or a new server, they'll copy the config file and then forget to rename, you know, create a new stanza or rename. If you do that under the system, you'll just get rejected WAL. It won't allow you to put the WAL for one database into another database's repository. Extremely important. And then the big thing here is, you know, since the beginning of the year, we've supported parallel archiving. So this is actually done asynchronously, but from the standpoint of Postgres, it looks synchronous. And the way it works is anytime Postgres requests calls the archive command and requests that WAL be pushed, backrest will spin up a background process, and it will peek inside the archive status directory in Postgres and see if anything else is ready to be archived. Postgres creates these little .ready files on disk to determine which things are ready to be archived. And so we can actually use that to look ahead to things that Postgres hasn't requested yet and go ahead and spin up a process. Now, meantime, the original process that fired off the async process will return immediately. You know, if it finds an indicator that says that WAL was archived, it'll just return. So Postgres can keep calling the archive command, and the async process in the background will keep working, and the two work together to, you know, get your WAL copied off as expeditiously as possible. So you might be asking, and this is a pretty common question, do you support PG Receive Xlog? And currently the answer is no. The reason for that, and we are planning to, although we're going to interface directly with the protocol layer rather than using the PG Receive Xlog binary itself. The reason we don't is because there are a lot of basically performance limitations built into that model. And only in recent versions of Postgres have some things been built in that are going to allow us to sidestep those issues, and it may even be version 11 before I can really get the thing working to my satisfaction. This method that we have here is extremely fast. So even very high volume databases can use this method. Compression is parallel, all the protocol stuff is in parallel, so you can really take enormous advantages if you're pushing off to S3. That can be done in parallel because S3 per stream can be really slow. Just creating an empty file in S3 takes about 1 second, which is pretty slow. So, but you can parallelize that and get some real performance benefits from that. But currently no PG Receive Xlog, although we are working on that. I'm going to kind of gloss over this, but tablespaces and links are fully supported. So if you've got PG Xlog linked off, or you've got PG stat linked off or whatever, you can back up and restore databases basically with any kind of topology. All right, so here's an interesting feature, and this is something that was frequently requested. So the question I've gotten many times over the years is, can I restore a single database out of a cluster? And my answer was always no, not in a binary backup. You could do it in a logical backup, like pgdump, but you can't do it from a binary backup. But Stephen Frost and I sat down and figured out a way to do it. And essentially what we do is we restore all the files for the databases that you're interested in. We do this by storing the catalog of databases when the original backup is done. So we know where it's going to be stored on disk. And then everything else is restored as a sparse 0 file. So initially all those files take up 0 bytes, although they are going to take up some inode directory space, of course. And then you replay the wall. Now the interesting thing is, if the wall makes modifications to the other databases that you're not interested in, those will be replayed into those files, and those files will start to grow. So the databases that you didn't restore will grow by the amount of wall that's contained in the wall that you're replaying. Could be a lot or it could be a little. It kind of depends on your particular use case. Yes? Well, the database, the backup process itself is going to force full page writes during the backup. So it's a good question. Let me repeat it. He said, do you need to turn on full page writes? Now, full page writes are turned on by default in Postgres, but you can turn them off because there are some file systems like ZFS that claim to deal with this problem for you, and you don't have to. I'm a little skeptical sometimes because I haven't seen proof of it, but you'd have to prove a negative. You'd have to prove that it fails, and that can be very difficult to prove. But even if you have full page writes turned off, Postgres will enable them during the backup. They have to be on so that the backup will succeed. Because at this point, you don't know where this data is going. You don't know if you can trust that file system to preserve things. So good question, but no, you don't have to worry about it. It's built in. And then when the wall replay is done, you'll have the databases that you wanted will be fully up to date. And the databases that you didn't want will be in some kind of strange state, where they'll be mostly empty, but they might have some update or insert records from the wall. I know this is a little bit weird, but you can't connect to them. I've made sure of that. So if you try to connect to one of those databases, you'll just get an error, and it won't allow you to connect. So the only thing you can do is drop them. It's the only command that's allowed. So a little hacky, yeah. We've thought about at some point maybe getting backrest to, hang on a second. We've thought about perhaps at some point getting backrest to go back after the recovery and clean stuff up. But It's actually a lot harder than it sounds because there's really two parts of a database restore. There's the actual restore, which BackRest does, right? So it pulls all the data from the repo that's required. It writes the recovery.conf. It sets up the archive command, or the restore command rather, and then BackRest stops. And that's the end of BackRest's responsibility. And then the Postgres starts up, and it actually starts requesting wall segments from the repository and plays up to the point in time that you're interested in recovering to. And BackRest is not involved at that point at all, so we would actually have to kind of figure out how to re-inject BackRest into the process. For now, certainly for the people who are interested in this feature, this is fine with them. They're not concerned about they're generally not concerned about these other databases, so they're happy to drop them or just leave them. Sometimes it's just that they want some data and they don't want to have to recover everything. Some people run thousands of customers inside a single cluster and they don't want to have to do that restore every time. Backup from standby. Oh yeah, go ahead. Yeah. Okay, so yes, in theory. The reason why we haven't done that yet is on disk, it's very easy to tell where databases live. It's a lot harder to tell where tables live. So in order to do that, you need to start poking into the PG file node map. And because a lot of the IDs on disk aren't, you can't just know them from the table name. You've got to query the database and then go. There are some problems here, but we're actually looking at table level restore as well. And it would work under the same philosophy, but we'd have to store a lot more information so that we could identify that particular table, plus all of its forks. So you've got the table and then the free space map and the VM map, and that sounds pretty easy, but then you've got what about toast? So those will actually have different IDs. So you need to be able to pull in all the toast tables as well. It actually gets a little bit complicated, and for most people, database level restore was enough, so we've stopped for now to move on to other important features. But it's a good point, and yes, it is possible. Just more complexity, of course, as always. All right, backup from standby. This is a very important feature to many people, and Postgres has a backup from standby facility. So you can start a backup on the replica and do your backup from there. We did not use it. We actually came up with our own backup from standby method. I spent several months researching the new method. So essentially what we do is we actually create a backup that looks just like it was taken on the master. So just like a normal master backup, we start the backup on the master. We wait until the replay location on the standby reaches that location at the start of backup. And then we copy all the replicated files from the standby, and we copy everything else from the master. So essentially what you get is a backup that looks exactly like it was taken on the master, but actually is taken from the standby instead. Most of it. Right, so some things are copied from the master. Mostly it's small files. But for instance, if you're storing your Postgres logs on your master, it's going to copy those as well. I always encourage people to store their logs actually in a separate directory, not in the Postgres data directory. One of the reasons why we did this, we went to all this trouble, is this allows us, now we haven't coded this yet, like I said, our idea is we're always thinking about parallelism, even if we can't implement it yet, right? So the reason why we came up with this new method, first of all, we think it gives you a better backup. The other thing is it's going to allow us in the future to backup from multiple standbys. So now we can use all your available standbys to do the backup and spread that load out as much as possible. And when you combine that with Delta Restore, highly performant ways to do both sides, you can see how this can give some real advantages. Now, so far we have not done that. Sometimes people ask me why we haven't implemented things that look really easy to implement, and my answer is always testing. We have a very strong testing ethic on the BackRest project, so essentially we don't code anything that we haven't written tests for. And so even though this would be relatively easy to code, now we've got to go test it and ensure its correctness. And testing is often the bottleneck. We probably spend, for any given feature, we spend about 80% of our time writing, verifying, reviewing test code, not the actual code. The backrest code base is relatively small compared to the test code base. So, so a lot of times if something's not implemented, it's because we haven't had time to write the tests yet. Because if I can't verify it's correct, I don't want to push it out there. So, S3 support. Anyone here interested in S3 support? Couple hands, good. This is a really often requested feature. This is another thing that part of the delay was because the client libraries that exist don't really subscribe to the backrest philosophy of not ever doing anything at rest, doing everything blockwise and stream, etc. So basically I had to write my own interface to S3. Now I used an HTTP client, right? So I didn't start from scratch. But we implemented the S3 protocol ourselves so that we could make sure that it was as fast and efficient as every other part of backrest. We abstracted the storage layer. So whether you're writing to POSIX, or there's also a CIFS option, which just disables certain fsyncs and directory links and stuff like that don't work on Microsoft, or S3, you get all the same features. Because backrest talks to this abstraction layer, and as far as it's concerned, it doesn't care what's below that. The data could be locally, it could be away. Backrest thinks that S3 is local because all it sees is a storage driver, and it tells it, go store these things or retrieve these things for me. And it's very efficient. Here's another area where parallelism really pays off because S3 itself is quite slow to create new objects. So by parallelizing, we can, but there are millions of, or thousands or hundreds of thousands of S3 servers. So by parallelizing, we can spread that load across S3 servers, get a lot of performance benefits. And we support version 8.3 and above. And if you think no one's using 8.3, you'd be wrong. There definitely are people using 8.3. In fact, we were working with someone last week who was running 8.3 with Tablespaces even. So, and it's a 2.5 terabyte database. So it's not even a trivial installation. Pretty interesting. So anyone here running 8.3? 8.4? Okay, 9.0? 9.1. Okay, so those are obviously the databases I named are all end of life, right? The Postgres project does not support them anymore, but we still do. Older databases still need to be backed up. They're people too. They need some love, so we try to give them some love. Let's talk about performance a little bit. This is kind of an older slide. I actually have made some improvements, but the general numbers have stayed the same. Essentially, what I was trying to do here was compare, since rsync doesn't do compression, I was trying to compare backrest to rsync if you rsynced the files and then compress them afterwards. And you can see that, even with a single, even with one thread, all right, so so with a single thread and with no compression, like no destination compression, which means you're just doing compression on the network, rsync is faster. Rsync is a more efficient implementation. Rsync also is not doing SHA-1 checksums, which cost. But you can see as you start to parallelize, things get faster really quick, and then they just keep multiplying. Backrest uses separate processes for, compression. We used to use threads. Threads were actually fairly efficient for compression, but the actual signaling, the messaging to actually send messages around was extremely inefficient in Perl threads. So instead we moved to process, we're using RPC for everything, and so you could basically, the scaling now is essentially linear. If your disk can supply data, you can run as many cores as you want. The most recorded to this point are 80 core backups. And this is for an installation that's so large and so busy that they can't do replication because Postgres replication won't keep up. So what they do is every 4 hours, they do a complete backup of their master and a complete restore, a delta restore, to their to replicas. And that's how the system works, because they simply, the single-threaded replication, replay on Postgres simply will not keep up. So it's an extreme situation, but it gives you an idea of how scalable this is if you have the resources. Now what you'll find in reality is you can clog up your network very quickly. If you're unfortunate enough to be working on a 1 gigabit network, then you can only run 4 to 8 cores. After that, you're simply going to clog your network. You might find that if you're running on good old-fashioned spinny disks, which many people still are, I/O will be a bottleneck. These days, systems tend to be pretty core-heavy, and BackRest works with cores very efficiently. So you can easily have more cores than you can accommodate in either I/O, disk I/O, or network I/O. But if you find the right balance, you can back up extremely quickly. Although, as I said earlier, don't back up any more quickly than you have to. Don't put that strain on your system if you can avoid it. So, in addition to obviously working on BackRest, I've also been thinking about how can we make Postgres better with regard to backup. So, some of the things that have been contributed recently that I've either written or contributed to are excluding certain files and directories. So there are actually a number of files and directories in the Postgres directory that are rebuilt on restart, or can be rebuilt on restart. So last year, I went through, audited the code, identified all those, worked with the people who had originally written those subsystems to verify that yes, in fact, they're not required. And I not only put that into BackRest, but I contributed to Postgres as well. So now in 10.0, pgBackRest will also exclude those files and directories that are rebuilt on restart. Like, why even copy them? Something also put into 10.0 is making pg-stop-backup-wait optional. This is a little arcane, but basically Postgres also tries to wait for all the wall to archive. But since BackRest does it itself, this is a switch to tell Postgres, when the backup stops, just return. And I'll take care of making sure that all the wall makes it to the archive successfully. Non-exclusive backups. So this was actually written by Magnus, but I reviewed and tested it to make sure it works. This is a great feature. It allows you to run multiple backups at the same time. So you can run BackRest and a base backup, or 2 base backups, or whatever. It used to be base backup used this API, but it was internal only. External tools could not use it. Now they can. Archive timeout fix. This was written by Michael Paquier and reviewed by me and several other people. But anyone familiar with the archive timeout feature? Basically, what it does is it allows you to move an archive, a wall segment to the archive on a schedule. So if your database is really quiet at certain times of day, you can have one wall segment that sticks around for hours or even days, and there's important information sitting there. So what you'd like to know is that eventually, at some time interval, it's going to get out to the repo. This has been broken for a number of versions of Postgres. It used to work. Now, because of the messages that get written in for replicas, it looks like activity to Postgres, and Postgres is just constantly writing these things out, even if there's been nothing to write. So it was very wasteful. So that's been fixed. We're planning more exclusions. I have a patch which I submitted for 10. It just ended up being too complicated. There were too many changes to allow group read on PG data. Right now this is forbidden, but for security purposes, it would be nice to be able to do backups as not Postgres. Like someone in the Postgres group who has read-only privileges, it would make it a lot safer. If, God forbid, there are any bugs in Postgres or BackRest, it would protect you from those bugs. I'm looking at a way to pass multiple wall segments to the archive command. Right now, the biggest bottleneck on archiving using that method is the number of times that Postgres has to call the archive command. And the startup cost of that command limits the total number of wall segments that you can push. And we're also looking at configure a wall segment size. This patch is being written by Bina Emerson. Unfortunately, I looked at it late in the 10 cycle and found enough issues that we weren't able to commit it in 10.0. But I am dedicated to getting this in 11. This will allow you to have larger wall segments for busier databases, which reduces the number of times you have to call archive command, et cetera, the number of fetches you have to do when you're doing recovery, all of it. And these are things we have in the pipeline for BackRest. Obviously, Postgres 10 support. You know, for those of you who haven't followed along, even if you've seen Magnus's talk about Postgres 10, what he doesn't mention is we changed and renamed a bunch of stuff. So pgXlog is now pgwall. All the functions and columns that were Xlog are now wall. So that's going to be kind of a pain. And it was a pain for me, but I supported it because I knew it was absolutely the right thing to do in terms of moving Postgres forward. So from my perspective as a tool author, I'm happy to make changes when they're for the greater good. These are for the greater good. I will tell you, if you have any homegrown backup solutions, Postgres 10 is basically going to break them. This might be a good time to think about, you know, an externally supported tool. We're looking at encryption. This will be a complement to the S3 service. S3 does its own encryption, of course, but the keys are still, whoa, that just turned back on. The keys are still stored with Amazon, so it's not perfect. So we're going to be building encryption. We're also going to be looking at Z-standard compression. Right now, we only support gzip. If you haven't played with Z-standard, which just got to 1.0 last year, it is extraordinarily fast is what it is. So you can get the same level of compression as you get with gzip 5 times faster. Or if you spend the same amount of time, you can get 30% more compression. Pretty cool. And the last feature that we're looking at very soon is parallel archive get. This hasn't been a big priority because generally speaking, BackRest can keep up with Postgres replay because replay is single-threaded, so getting archive single-threaded hasn't been that big a deal. But there are some edge cases where replay has outstripped archive get, so we're going to look at pulling batches of wall down to get that process as fast as possible. And that's all I got. I think I'm almost out of time, but if there are any questions, we probably have a few minutes. All right, well, thank you very much. Oh, sorry, there is one question.
When you talk about exclusions of some files and directories from backups, does it mean exclusion of no logging tables?
No. The problem is it can be actually very difficult to identify which tables are in that mode. So
I did it by identifying the files as that having the same named files with init suffix.
Right. So there are. So here's what we're doing, and we were working on a patch for this for Postgres 10, and we weren't able to get it done in time. What we're trying to do is move around some of the things in Postgres so temporary files are easier to identify. Because even Postgres, if you actually look at the recovery code where it's identifying which files are temp, it's actually doing, or unlogged, is doing it by recognizing the file names, which to me is a little bit scary. So using exactly the same method you've used, and maybe you looked at the code. But so what we're trying to do is work on moving those tables to a different directory, to like a pgtemp directory underneath, and that way you can just exclude that entire directory. Because actually right now the startup, since we introduced unlog tables, the startup cost of Postgres has actually gotten a lot larger because you've got to scan everything in the database, you know, all the files and check things. So yes, we were working on that. We were working on a patch and we were just not able to get it in for 10. It ended up being a bigger change than we expected, and we couldn't drop it on March 1st into the last commit fest.
Thank you very much.
But yeah, that's a great one, and we're working on that.
Can this tool be used for archiving some part of and restoring some part of large table, maybe partition table? So we have a very large partition table, maybe some terabytes or tens of terabytes, and we should store in database 1 month, for example. And another 3 years of this table we can place on the tape. Can we use this tool for archiving? old parts and restore some of them.
So actually,
we
this
need.
gentleman asked that question. Can you restore a single table out of a database? I may not have repeated it, and I apologize. Can you restore a single table out of a database? And the current answer is no, but we are working on it. So it is planned, but currently no, you have to restore the entire database currently out of the cluster. And you can't do a single table, but it is a planned item for the future. Okay?
Thank you.
All right, well, I think that really is all our time. So thank you very much.